Hello everyone, in today's video we're going to cover section 10.7, Inscribed and Circumscribed Polygons. After studying this section, you'll be able to recognize inscribed and circumscribed polygons, apply the relationship between opposite angles of an inscribed quadrilateral, and identify the characteristics of an inscribed parallelogram. First, looking at inscribed and circumscribed polygons, my two figures to the right, we have an inscribed polygon and a circumscribed polygon. So my top figure, triangle ABC, is inscribed in circle O. A polygon is inscribed in a circle if all of its vertices lie in the circle. So I can see that ABC all lie on the circle. And then polygon PQRST is circumscribed about circle F. So we can see that a polygon is circumscribed about a circle if each of its sides is tangent to the circle. So each of these sides here would be tangent to circle F. Now, the centers of circles have relationships, whether they're circumscribed or inscribed in a polygon or about a polygon. So my figure to the left, we have polygon PQRST circumscribed about circle F. Now, the center of a circle circumscribed about a polygon is the circumcenter of the polygon. Remember, circumcenter were the perpendicular bisectors. So if I drew in radii of circle F to each side of polygon PQRST, they would be perpendicular and bisect each side. And this would be for each radii that I draw in to the point of tangency of polygon PQRST. And then if I have a center of a circle inscribed in a polygon, so like my figure to the right, triangle ABC, these are the incenters of the polygon. And remember, incenter were the angle bisectors. So if I drew in radii to each vertex, it would split each vertex into congruent pieces. Next, we'll look at a theorem about inscribed quadrilaterals. So theorem 93 tells us if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. If I look at my figure to the right, we have quadrilateral ABCD inscribed in circle O. What theorem 93 tells us about this quadrilateral is that the angles that are opposite add to 180. So angle A plus angle C equal 180, and then angle B plus angle D equal 180. Now, the reason why is because if I look at the intercepted arcs of these angles, so for instance, if we look at angle A and angle A has intercepted arcs of BCD, and then angle C has intercepted arcs of DAB. Notice both these intercepted arcs make the whole circle. My whole circle is 360 degrees. An inscribed angle is half that measure. Half of 360 is 180. So theorem 93, if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. And lastly, looking at a theorem about inscribed parallelograms, theorem 94 tells us if a parallelogram is inscribed in a circle, it must be a rectangle. So I have two figures. My first figure, we could call this a rhombus. We can see that rhombi would not be inscribed in a circle because all the vertices do not lie on the circle, where rectangle EXTR is on the circle. Therefore, if a parallelogram is inscribed in a circle, it has to be a rectangle because that's the only way the vertices would lie on the circle. Now, with theorem 94, we can conclude the following things. So if I have rectangle ABCD, and it's an inscribed parallelogram, then BD and AC would be diameters, O would be my center, OA, OD, OC, OB are radii, and then I can create right triangles and use Pythagorean theorem. So I could say AB squared plus BC squared equals AC squared, and so forth. In today's lesson, we learned an inscribed polygon is a polygon that has all its vertices lie on the circle. A circumscribed polygon is a polygon that has each of its sides tangent to the circle. If a quadrilateral is inscribed in a circle, its opposite angles are sup. And if a parallelogram is inscribed in a circle, it has to be a rectangle. That's a wrap on today's video. We'll see you in the next one.